Hello, hello! Stay a while and listen. It's good to have you here. How are you? I'm happy, and I hope you're happy too. I am Pinkfred, a computer scientist that works as a software engineer and that is also studying to be a master in software engineering. I, during my studies, recently stumbled upon a very interesting paper that I want to share it with you here. I want to present to you this paper about electronic voting. It was published in 2018 by Javusk, Koch, Jabuk, and Dalkilish. Their paper is called Towards Secure E-Voting Using Ethereum Blockchain. And this paper is part of a broader research related to e-voting systems. The results shown by the paper are not a perfect solution, but they are promising and a step towards electronic voting. So the deal is, when groups of humans need to make collective decisions, they often vote for it. So voting can happen in different ways. For example, on a small organization with a few dozen people, voting could require unanimity to make a decision. Whereas countries with hundreds of thousands of citizens, they can use voting to hold democratic elections based only on the count of votes. Or a medium-sized organization that they could require the majority of votes to make a decision. In some cases, people can vote by simply raising their hands or vocalizing their choices, like yes or no. In some other cases, people go to specific places and write down in pieces of paper their choices. And then someone else will take a look at all those pieces of paper and count the votes one by one. There are many successful examples of online polls and questionnaires, but not for online elections for governments. Basically, because official elections is an essential element of democracy. They are required to be robust, provide transparency, privacy. The privacy refers to the identity of voters. So if I'm going to vote, my identity should not be disclosed. The transparency means that everyone should be able to check the results, and you should not have to trust someone on the results. So people can trust the numbers and not someone. And the robustness means that fraud can't happen. So no matter what you throw at this election system, the voting system, it needs to stand robust, must not fall to any fraud attempt or attack that you might try to do on the system to take control of it. So with democratic elections, there are always questions open related to these requirements. How honest are the people responsible for the voting system? How can people trust the system? How can we be sure that nobody is manipulating the results by changing votes before they are counted? How can we verify the transparency of the system while protecting the identity of the voters? How can we assure that a voter has the right to vote and is not like a dead person that is attending the voting? And there's also a problem with scalability of the voting systems that can be very costly. So having 10 voters can be very easy to count 10 votes, cheap and fast. But what if we're talking about millions of voters? You have to have many people to count those things, and you have to trust all those people. How can you achieve transparency? So anyways, voting nowadays is not really done very well. It's a thing that we should and we need to improve too, because like I said, because I think we can all agree that this is a very important element of democracy, of a human being being a person, citizen, no? So an improved voting solution should directly tackle these questions to improve on the currently deployed systems. So currently elections nowadays, they lack transparency. They are expensive to run in large scales. So it's hard to ask for votes in the sense that there can't be an election for every now and then to ask for small things. You have to ask for big questions, and people have to go there sometimes, and it's hard for them to go there. It's the whole logistic thing. In most cases, physical presence is required to vote. And voters have to trust the central authority to make sure that they can do the right thing. So no one can be 100% sure that no fraud is being committed. There's always room for a conspiracy theory. There's always room for someone to say that the elections, they were frauded. There's always room for that, and there's always a possibility, and we can never be sure if there was or if there wasn't, unless someone actually goes there and confess. So even though electronic voting systems are being studied intensively, very few implementations are reliable and in use today. Brazil, for example. I'm Brazilian. Brazil uses an electronic urn instead of paper for their elections. It can be seen as an improvement over paper-based voting because even if people still have to physically attend the voting venue, counting the votes can be done automatically instead of manually. counting pieces of paper one by one. However, one can argue that it's even easier to manipulate the results of an election done like this because it still requires trust in the administrators of the system and the machines that are the urns. And people can also attack the electronic urns, as demonstrated by the Professor Pedro Rezende, who taught me computational security during my graduation. So I actually had class with the professor that hacked the electronic urn and told everybody, hey, here, it's very easy to hack this. This is an example. But anyway, other examples of electronic voting are mentioned in this paper. For starters, there is Estonia, where there is a very robust and reliable centralized electronic voting system, where voting is done online. So citizens of Estonia are provided card readers that they can use to read their IDs to authenticate with the system and vote. It puts citizens close to the decisions made by their government by allowing them to digitally create petitions and proposals for acts and laws at the parliament's website. But it's not a perfect system. You see, it's centralized. So it creates a single point of failure that can be the target of distributed denial of service attacks, for example. And administrators of the centralized system still have the power to act maliciously. It's also not scalable because of the need for the card readers. The system has seen a weak penetration of only 30% among the population that could vote, and Estonia has a relatively small population of 1.3 million people, which is 1,000 times smaller than the population of China. So there are questions raised about the scalability of the system in Estonia. Switzerland is yet another example. There, e-voting has been in use for years, but it's not free of criticism that points that the system that works on its own infrastructure is expensive, is complex, and lacking transparency. It has security flaws, and there has also been concerns with vote quality because the de-ritualization of the voting procedure, like going to the place, to the temple to vote. This de-ritualization of the voting procedure can result in people voting without much reflection on what they're voting for. It's don't. Another initiative is the website followmyvote.com, where voters can sign up using a government ID and they can declare votes anonymously by putting trust in the system. The system then does some mathematical computations to put a margin on the results and ignore fake votes. It's far from being a solid solution, and the results are not truly transparent. It's not meant to be a voting platform, but rather to try to validate election results. But it's an example. And there's also another very popular website called strawpoll.me, a simple polling website that shows the power of online voting to be convenient. But it has very weak security because voters don't even need to authenticate, and votes can be easily duplicated. You can vote many times, making it unusable for official voting. It's more like for quick stuff and with a small group of people that you trust, a small community voting. A very good solution is Electronic Runner, a software as a service solution where users can define elections, select who will vote in their election, and how long will the election last. It's similar to the system used in Switzerland, and its major downside is that it requires trust in a central authority, which are the people behind this website. So improving voting systems is a really hard task, but improvements in this area can benefit countless people in so many different communities. We're talking about voting, elections. This brings us to talk about blockchain technology. It's the same technology behind the very famous cryptocurrency Bitcoin and its successors. Probably you heard about Bitcoin. The blockchain technology is famous for its usage in cryptocurrencies, but it's far from being limited only to that. And there are many studies that suggest that it could be useful for more than just cryptocurrencies because there's a very high degree of transparency. Systems that run on the blockchain technology, they're very transparent. To understand why the system is so transparent, one should understand how the blockchain technology works on the surface. It's actually not really that complicated, and I'm gonna explain to you in 3 different ways. They are made of blocks which contain transaction data and other related information. This means that every blockchain must have a mechanism that decides which transactions to add to the chain, which node operators to listen to, and how to resolve potentially conflicting information. In other words, blockchains use consensus to settle upon and finalize data. So to explain it differently, blocks of information are written to the network and they are all chained together. This means that whatever happens in the network is also replicated across all the nodes that are present in the network. And it's also linked to everything that's happening so far. So everything's linked together and distributed, and there's consensus. In other words, when something happens, there's a consensus and everyone becomes aware of it. It's like the network of perfect gossip. So if we're talking about a money transfer, I can't simply give money to someone under the table because everybody needs to know about this transfer. If it's not everybody that knows about this transfer, it's not valid. With blockchain, this kind of transaction would be written on the blockchain so everyone would be aware of it. A consensus. And if we're talking about a piece of code written to the blockchain, this piece of code would be replicated throughout the entire network. And since all the blocks are chained, this means that once something is written on the blockchain, it gets cemented in there. Virtually impossible to be changed. Immutable. Where anyone can go and read, check what's written in there. And the code is going to be always that. So, to explain it in yet another way, you can think of blockchains as if they were ledgers, holding records of a company's financial transactions. So a ledger is a notebook where business can write their income and expenses. Just like each page in a ledger holds a certain number of transactions, so does blocks in a blockchain. Also, blockchains are known for being secure because the actual chain of blocks, or ledger holding the transactions, is usually distributed across tens, if not hundreds of thousands of nodes. This is why blockchain systems are also referred to as distributed ledgers. Since each node has its own copy of the ledger, it's very hard for someone to change that transaction without all the other nodes noticing. A transaction can be anything from financial data to partitures of music to copyright stuff to a recipe for the cure of COVID-19 or computer code that can be executed by nodes on the network. Once a node receives a transaction, it validates it, adds it to that block, and then distributes it to all the other nodes who then accept or refuse the block. If the block is anonymously accepted, it is added to the chain. And for the many cases, the data being written to the blockchain can be encrypted, making it so transparent, but also private at the same time. Because it's going to be there, anyone can go and read what's on the blockchain, and they're going to see the data, but it's going to be encrypted. So it's going to be transparent and private at the same time. So, to sum it up, using cryptography and distributed consensus mechanisms, blockchain can provide a unique combination of permanent and tamper-evident record keeping, transaction transparency and auditability, automated customs functions with what we call smart contracts, and the reduction of centralized authority and information ownership within processes. That's right. You heard it right. You heard it right. The reduction of a centralized authority to almost nothing, meaning that we can have a system that works on its own and the users don't need to trust anybody, but this open source auditable system that you can audit it yourself. So the blockchain technology can be an ideal platform for implementing e-voting, like the proposed implementation provided by the paper, which shows how they implemented a voting system with Ethereum, a decentralized open source blockchain. And Ethereum features the smart contract functionality. So the authors of this paper, they use the Ethereum blockchain technology to design an e-voting system to be reliable so that the whole election process is transparent. Votes are immutable. People can authenticate using credentials, and the platform has provability so that only real people can vote. They also designed the system to be distributed, meaning that there is no need for a central authority. And the authors suggest that the operations that happen in the system should be real-time. And in their design, smart contracts written in the Solidity programming language are executed by the blockchain nodes every 15 seconds. And the transactions containing the votes are added to the blocks in exchange of ethers.
the cryptocurrency of the Ethereum network. I know that this might be a lot of information for you for the first time, but keep up with me, we're almost there, concluding something, and this is really interesting. Electronic voting. So before going into detail about the implementation, about how they did this, keep in mind that it's not a concept that is not yet ready to be used in official elections. This is because Ethereum might still have scalability issues which are unknown to the authors, and there's still a problem open because there are transaction fees to add something to the public Ethereum network. You need to spend some ethers, which are cryptocurrency. So voters need a small number of ethers in their Ethereum wallets to be able to cast their vote. And another open issue with this solution is that it might be way too transparent so that anyone can access the blockchain and see the source and destination of a transaction, meaning that providing anonymity for voters without compromising the transparency of the general voting process is still an open problem. But anyway, you can deploy the solution to test it yourself in an Ethereum test network such as Rinkeby that won't cost you real ethers to run. So getting into the details of the implementation, that is the immutable code to be written and executed in the blockchain. Here you can see a code snippet that shows the structures and variables necessary. The voter is defined as a struct in the Solidity programming language, and voters are collected in an array which they have some properties, and may have much more depending on the use case scenarios. The flag is voted indicates that whether the voter has cast his vote already or not yet. The vote variable stores the choice of the voter among all the candidates, called proposals in a broader sense. An ID is an Ethereum wallet address associated with a voter account in the Ethereum network. The address variable, chairperson, I love that they call it chairperson, I'm not chairman, stores the wallet address of the main administrator of the voting process. This administrator cannot manipulate the voting, but rather they have the ability to initialize the voting process and the voter objects, which will be assigned to real voters. So this process of assigning votes can be seen in this snippet of code. This function, give right to vote, can only be executed by the chairperson, which is checked with a basic if statement before giving the right to vote to an eligible voter. So the function vote is used by the voters at any time before the deadline for an election. This can be seen in this other snippet of code. Yes, we're looking at code. It checks who is trying to vote and if the voter can vote. And then the vote happens. Voters just send the ID of the proposal which they want to vote as a parameter, and their votes are recorded. Here, the last code snippet I want to show you. It's from the function winning proposal, which is not meant to end an election, but rather it checks every proposal, counts the votes, and then returns the one, who is the winner of the whole voting process as of the execution time. So here's a screenshot of the voting creation entry in the blockchain. This information here is publicly available to everyone tracking the network. You can do it, I can do it, anybody can do it because it's a public network. And here's another screenshot of a vote casting entry in the chain. This information is also publicly available to anyone, including you, tracking the network. Here is a screenshot of a voter's wallet right after voting, showing the receipt of the casted vote. This information can only be seen by the voter because these records, they can only be obtained from the voter's wallet. And the same privacy applies to this other screenshot here of a voter's query on the resulting of voting to see who won. So yeah, in conclusion, e-voting is still a controversial topic within both political and scientific circles, and blockchain e-voting implementations can address factors like privacy, integrity, non-repudiation, and the transparency of counting. However, authentication requires additional mechanisms, and it's a problem that's still open. Maybe you can solve it if you want to become a scientist too. There's a lot that can be done with blockchain technology, and there's a lot happening right now. The numbers are increasing and there are solutions being deployed, like in Colombia, where they will use Ethereum for an anti-corruption project. So among others, the authors of the paper also mentioned having studied various other blockchains, e-voting implementations. Like for example, a blockchain research paper that exposes solid methodologies for e-voting but doesn't show implementation details, and an Ethereum research paper that proposes a really good solution for e-voting but that requires a lot of computational resources for performing complex mathematical operations, which makes the system not friendly for the Internet of Things, meaning it's not a practical solution to be practically deployed for millions of voters. Yeah, it looks like we're gonna hear more about it because it can impact the lives of so many people. Good thing that you stayed on this video and you digested the blockchain technology. I want to give you my opinion about this, and maybe we can even discuss it further on the comments. So my opinion about the election aspect of politics is that it doesn't matter who is elected. People obtain power and they eventually become corrupted. So to me, the problem is that governmental systems are based on people that promise things. I would rather vote directly on the things being proposed instead of voting for the person that says they will make that thing happen. So for example, a candidate could promise to invest more money on education and less in the armies, could promise the discriminalization of substances, or could legalize the right for a woman to have control over her body and an abort pregnancy safely. But once in power, the same politician could simply not do those things, or even do things that go against these promises. So I would much rather vote directly on what's being proposed. Like, I would like to directly vote to decide if gay marriage should be legal or not, and not vote on the person that promises something about it. And instead of having a popularity contest to decide who will make things happen, I would rather that the people would be chosen for positions in government based on their knowledge and skills, like it's done when people go look for jobs. So to me, using e-voting solution is definitely a step into the right direction to make society better. Not only because it brings a lot of transparency to the table, but also because of the logistics aspect that would allow this kind of fragmented voting to take place. Maybe we can call it democracy 2.0. Democracy 2.0. So maybe one day we can all vote directly on the directions we would like to take our society using a trusty e-voting system instead of voting for people that make promises using a flawed system. So this is what I had for this video. Remember that we can talk about things in the comments. Thank you very much. Thank you for your attention. Thank you. If you know someone that might find this content interesting, please share my video with them, so maybe you can have a conversation about it with them. And I invite you to subscribe so you don't miss future videos. I do a lot of other stuff. So I would love if you stay to watch them too. So I hope I see you again in the future.